Hey, how are you? So today we're going to work on set 11. And what you have here for set 11 is apparently we're going to be looking at integrals. So let's get started. We're going to try to hit off the first three problems in the first go. So let's get started. All right, so with that being the case, let me just take a quick snippet of that. So with that being the case right here, we're going to be working on 1A, B, and C. So for the first one, let me just make this a little bit bigger. We're going to have the integral of 4x minus 5 dx. This is going to simply be 4x squared divided by 2 minus 5x plus c, and that is our first problem. To simplify, we're going to get 2 into 4, that's going to be 2, that's 2x squared minus 5x plus c. So that is my first problem. Pretty easy problem. So we're just running through that. All right. So for the second piece, notice we add 1 to the exponent and then we divide by that exponent. So we're doing the opposite of the integration process. Now, for this one, let's look at this carefully. Notice for these 9x squared, 4x, we can do that with those two, but we have 1 over x for the third piece of that integral. So notice if we have 1 over x, this yield, that's 1 over x, this is going to be equal to x to negative 1. And if you add 1 to negative 1 divided by negative 1 plus 1, technically I'm dividing by 0, which I cannot do. So if I'm integrating 1 over x, that's going to yield ln x. So let's see if we can run through it now. So this result here going to be 9x squared divided by 2 minus 4x squared divided by 2, and then the integral of 1 over x going to be ln x. So that's ln x. Again, because it's an indefinite integral, I'm going to generate a constant, that's c right there. So with that being the case, let me just make a quick correction here. It's supposed to be going a little bit too fast. It's supposed to be x plus 3 divided by 3. So notice we add in 1 to the exponent. After we add 1 to the exponent, we divide by 3. So with that, we're going to get 3x squared, 3x cubed minus 2x squared plus minus ln x plus c. And that is my integral for the second piece. Let's do the last piece now, part C. The simplest way to do this before we start the integration process is to simplify. If I divide everything by x, so we have x cubed divided by x plus 2x squared divided by x minus x divided by x would make life a little bit easier. So I'm going to have the integral of x squared plus 2x minus 1 dx. And with that being the case, what I'm going to have here, I'm going to have x cubed divided by 3 plus 2x squared divided by 2 minus x plus c. So that simplifies. We get x cubed over 3 plus 2 into 2, that's out. So we're going to have x squared minus x plus c. And that expression there going to be representing my integral. So let me just go over real quick. Just this one here we need to kind of emphasize. If we have 1 over x, that's going to be ln x. We have 9x squared. We add 1 to the exponent divided by 3, so we're going to get 3x cubed. We have 4x, add 1 to that divided by 2, we're going to get 2x squared minus ln x plus c. So that's the situation right there. We actually have the integral for all three problems. So that completes number 1. Okay, so we're going to now be looking at, I apologize, we didn't complete number 1 right there. Apparently we have 3 more pieces to complete number 1. All right. So for the first one, we obviously right here, we're going to have 2 over x. Again, that is same thing as 2 times 1 over x. So this is going to be, if I integrate that, that's going to yield me 2 ln x, right? because I recognize that right here is 2 times 1 over x. Take the integral of 1 over x, that's going to be ln x. Plus 3x, add 1 to the exponent, that's going to be 3 divided by 3, plus 3x squared divided by 2 minus 3x plus c. So to simplify, this is going to be 2 ln x plus x cubed plus 3 over 2x squared minus 3x plus c. And that right there represents my integral for part D. All right, so let's now look at part E. So for part E, we want the integral. We have the product right there. A simple way to do this is recognize the pattern. If I look at this carefully, I recognize that the number beside right here is going to be the derivative. So that's f prime of x times f of x. So if I have that as my result and I need to integrate f prime of x, f to the n of x, I recognize as f of x is right there. What I simply need to do, this is going to yield the result, f to the n plus 1 divided by n plus 1. So simply the integral of this problem, 6 x to the 5th x squared, x6 plus 3 to 7, going to simply be equal to x to 6 plus 3 to 8 divided by 8. And we can do that problem in one breath. Now, what I want, again, we just need to spot what is going on right here. This is the integral of x squared e to x cubed dx. Now, if I differentiate, if I can spot what is going on right here, if I differentiate e to that, e to the x to the third, if I differentiate that, the result going to yield 3x squared e to x to the 3. So I recognize that this right here is almost a derivative of what this is, e to the x to the 3. So what I could do is put a 3 right here and take it back out. I only can do that with a constant. Now if I have that, I can just simply write in the reverse, because I know that if I differentiate this, I get that, which means then if I integrate that, I must get that as my answer. So if I differentiate this, I get this. If I go this way, if I differentiate, if I integrate that, I must get back the original thing. So this is going to be e to x to the third, and I have a third out there, so this is going to be 1 over 3. So this is going to be e to x to the third divided by 3. And that there represents my integral for an expression looking like that. Now notice that if the integral didn't, if the expression in front of e wasn't the actual derivative, it would be significantly more complex to integrate. But because it is relatively simple to integrate given the situation. Alright, so with this being the case now, number 2, they said to find the area of the region bounded above by the graph. And so the graph is negative x plus 2, x plus 1 in parentheses, times x minus 3 below, and the x-axis and the vertical sides of x equal to 0 and x equal to 3. Now, point to note, we recognize that's quadratic, so my expression going to be looking like this, right? I know that if I sketch that quadratic, it's going to be intersecting at negative 1, and it's going to be intersecting this at 3, obviously, and that's my situation right there. So we have the x-axis. This is negative 1, so x-axis. So we need this point. Let me use a different color to illustrate. So let me use a red. We have the vertical line, which is x equal to 0 and x equal to 3, and the x-axis. So we want this region. Pretty much. So the integral of that is going to be the integral of from 0 to 3. And that's going to be negative x plus 1 times x minus 3 dx. So with that being the integral, now I simplify. I'm going to have the integral from 0 to 3. That's going to be, put back my negative sign. If I expand that, I'm going to get x squared minus 2x minus 3. And that's going to be equal to the integral from 0 to 3. From that expression right there, if I simplify, this is going to be negative. I have a negative in front. Integrating that going to yield, let me put up my 0 to 3 right here, x cubed divided by 3 minus 2x squared divided by 2 minus 3x equal to, again, we put in back our 3 to 0. So that's going to be negative x cubed divided by 3 plus x squared plus 3x. Now, with that being the situation, now I need to just simply plug in 3 and 0. If I plug in 0, I know everything going to drop out. So I plug in 3, and then we're going to substitute 3 for x. So substituting 3 for x, I'm going to have negative 3 cubed divided by 3 plus 3 squared plus 3 times 3. With that being the case, minus 0 plus 0 plus 0, because all of these would be 0 if I plug in 0. So my result here going to be negative 9 plus 9 plus 9, which is going to equate to be 9 units. Now I could actually do this integral pretty much very fast on the calculator. If I pull my calculator up, the integral right here, if I turn this on, simply going to be, if I hit math on the TI-84 calculator, scroll down real quick to number 9, hit enter right there. That's going to be my integral. I'm integrating from 0 to 3, so put 0 in right there to the top, put 3. And if I put that in, equal to, put my minus, right, put a parentheses, another parentheses, and then my expression right there going to be x squared. So I put x squared minus 2x okay, let's just clear that out a bit. So that's x squared. Let's go down. That's minus 2x minus 3. And that I'm integrating that with respect to x. So that's going to be x right there. So if I check, my result there is 9. So that verify what I just calculated in terms of my calculation. All right, so let's keep it going. That's number 2. We're going to stop right there, and then we're going to now work on number 3. All right, number 3, they said that find a value for b for which the integral from b to 2b of 1 over x plus 1 dx is equal to ln 2 plus 6. All right, now with that being the case, we just need to integrate this as is. So let me just take my quick snippet of this. So with this quick snippet, we recognize that this here going to be the integral from b to 2b of 1 over x plus 1 dx. This is going to be equal to ln x. If I integrate that, I know I'm doing it from b to 2b. So that's going to be ln x plus x. Substitute 2b, I'm going to get ln 2b plus 2b minus ln b minus b. So work this out. I'm going to get ln 2b minus ln b plus 2b minus b. So this is going to be ln 2b divided by b, using the laws of logarithm right here because I'm subtracting and can divide those. B from that going to simply be b. So this here going to be ln 2 plus b. Now if you notice, this expression matches that expression pretty nicely. So b here is obviously going to be equal to 6, and that completes number 3. All right, so let's look now at number 4. Number 4, we have the integral of e to the 2x times e to the 2x plus 1 all to 4. Now, again, this integral looks a little bit daunting, but it's pretty straightforward. We recognize that we have e to the 2x times e to the 2x plus 1 all to 4 dx. Now, again, it is very straightforward here that if I differentiate e to the 2x, my result is going to be 2 e to the 2x. So let's check this. So we have e to the 2x right here. If I differentiate this, so if I find, say it was d by dx, or in better words, let me just write d by dx. If I differentiate that, the result going to be 2e to the 2x. So if I integrate this with respect to x, so let's call it f of x, with respect to x, my result going to be e to the 2x if I go in the reverse. So it's pretty straightforward from here because 1 is kind of not important, because 1 here, if I differentiate it, is 0. So that is kind of not important in this problem. So we just need to recognize that. Once you recognize that, it is in the same pattern like what we identified before. It is f prime x times f of n x dx. And that's going to be equal to f of n plus 1 divided by n plus 1. So with that being the case, what we're going to have right here for this problem number 4, going to simply be, I'm going to put, let me use a different color to highlight this. Since the derivative of inside is going to yield this additional 2, I'm going to put that 2 and I'm going to take it back out. So if I do that, I'm going to simply have a half times e to the 2x plus 1 all to 4 plus 1 divided by 4 plus 1 plus c. That's going to be e to the 2x plus 1 all to 5 divided by a half times 5 right there, going to be 10. So that's going to be 10 at the bottom plus my constant. And that's my integral for number 4.